So in the last class we have discussed about I2C protocol, right? In the present class we will discuss about APB protocol. In that what is on-chip protocol and what is off-chip protocols. You need to know that. Okay, on-chip protocols means it is communication. The communication is established inside the sock. Okay, inside the sock we have some blocks. What are the blocks are here? CPU and then high speed peripherals, all these things. Okay, so high speed communication devices, whatever the high speed communication devices are there. Okay, it will communicate in between the soft components like CPU, DMA and memory, GPU, all these components. In between these components we need a communicator. For that we are using AMBA protocols. AMBA means Advanced Microcontroller Bus Architecture. Okay, so these protocols we are using in between the soft components, communicating is happening. The key features of on-chip protocols is high speed, low latency. Latency means delay. Low latency, short distance communication it is using, and also consuming power is also less, and designed for on-chip communication. In between the components we need to communicate each other, and typically synchronous. There is no asynchronous in the on-chip protocols. Okay, here common on-chip protocols are AXI, Advanced Extensible Interface. So AXI is a type of protocol. It is a high performance memory mapped bus. So this type of protocol we are using here. So what is the purpose we are using AXI protocol means it uses that high speed communication in between the high performance blocks. What are the high performance blocks? CPU, GPU, DMA, all these blocks are high performance blocks. Okay, it is developed by ARM. Okay, similarly AHB, Advanced High Performance Bus. So it is similar to AXI, but fewer operations are not available in AHB. So AXI we are having separate read-write channels, so communication is happening high speed way. So here also high performance bus. Here high performance memory mapped bus. This is the high performance bus. Okay, we need to communicate between the high speed peripherals to low speed peripheral devices, and then high speed peripherals also we will communicate it. See, the communication is in what is the purpose we are using AHB here? Communication between high performance on chip modules. Okay, whatever the high performance on chip modules are there, in between those we need a communication. So for that we are using AHB. So it is also developed by ARM. And then APB. See, all these are high performance buses. And then external devices we have. So those are having some low performance devices are there. Okay, or low peripheral devices are there. And then low bandwidth devices are there. Further, we are using APB protocol. APB is a low bandwidth peripheral communication device. Okay, so it will communicate with UART, timer, GPIOs, and then I2C, SPI, all these protocols we will communicate through APB protocol. It is also developed by ARM. And AXI-4 is also AXI protocol. It is having some other features. So lightweight AXI protocol. So simple protocol. For that simple interface registers purpose, we are using AXI-4 Lite. And it is also developed by ARM. And tile link, chi select, all these are coherent hub interface scale extension at low latency. So this is the full form of chi select. So chi means coherent hub interface for scalable extension at low latency. Okay, so it is used for scalable interconnects. We are communicating between the different high performance coherent on chip communication. We are using chi protocol. Okay, chi select protocol. It is developed by UC Bharti. And then a tile protocol also scalable interconnects, so it is also used for processor communication, like RISC-V based SOCs on-chip communication we need to establish. Okay, at that time tile link protocol is used, so it is also developed by UC Berkeley. Okay, so here off-chip protocols are whatever the external peripherals are there, those external peripherals need to communicate with SOC. Okay, there is a communication between SOC and external devices. In between these we need a communication. Okay, so for that SOC is we are using on-chip protocols. What are those on-chip protocols means? SPI, serial peripheral interface, I2C, inter-integrated circuits, and then UART, universal asynchronous receiver and transmitter, and USB, universal serial bus, PCIe, peripheral interconnect, so peripheral component interconnect express, and then MIPI, mobile industry processor interface. All these protocols are used to communicate with the external devices. So MIPI is used for camera, so high speed serial bus, high speed serial communication type, it is a high speed serial communication. And then PCIe is also high speed serial communication is happening. In this on chip protocol we have synchronous as well as asynchronous also we have. Okay, in off chip protocols we have synchronous as well as asynchronous. In on chip only synchronous it is available, asynchronous is not available. With respect to clock only it is sending. Okay, without clock it is on chip, without clock it is not sending. See, these off-chip protocols all are serial communication protocols. Okay, MIPI and PCIe is high-speed serial communication protocols. So we need to communicate with CPU, GPU, SSD, all other devices. We need to communicate with PCIe, and then I2C. All these things we knew, right? LPDDR also. DDR that means memory devices. So double data rate. DDR means double data rate. LPDDR means low power double data rate. So low power double data rate devices also basically it is a memory interface type of devices we are communicating with. Okay. So what type of memory devices? External memory devices like DRAM and then all these things we are using. So it is developed by ZF. And then here coherent and some flash memory, EPROM sensors all are connected through SPI protocol. And then it is also connects low speed peripherals. I2C connects the low speed peripherals and sensors, all these things we are connecting through I2C. I2C is developed by NXP, and then SPI is developed by Motorola. And UART is a communication with modems. So that means we have some debug interfaces are there. Modem debug interface is there. So modem means we are communicating with like what internet. So internet we have modem, right? Okay. So at that time UART will be communicating, and then somewhat some tracing purpose also we are using UART. Okay, USB, you know, right? External peripherals like mouse, keyboard, all these things are communicating through USB. And then PCIe, we have so SSDs, GPUs, and then ICs, networking chips. Okay, so all these communication. What are the main differences on chip versus off chip? Okay, so speed. Which one is high speed? On chip protocols are the high speed. Off chips are low speed. And here distance, short distance communication on chip. Off chip protocols are long distance communication is available. So power consumption is low in on chip and high in off chip. And signal integrity easier in on chip and then challenging in off chip. Signal integrity means we need to communicate the one device to other device. These signals are different, these signals are different. We need to integrate these signals. We need some protocols. So that will be on chip protocols. It is easily communicating because inbuilt integrations are available, and then there is no problem to communicate with each other inside the soft devices. And here signal integrity will be some challenging because external devices are having some other components and internal devices are having some other components. We need to give some external connection devices ports. So how the laptops are having USB ports and then HDMI cable, Ethernet cable, all these things are there, right? So based on the ports, we are communicating each other. And most of the things serialization on chip protocols are usually on chip off chip protocols are usually serialized protocols, but on chip protocols are not serialized. And then synchronization, see, on chip protocols are always synchronized with clock, and then off chip protocols are somewhat asynchronous with the clock. Okay, so this is the on chip protocol and off chip protocols. Okay, so these are the topics we need to discuss about the APB protocol: introduction to AMBA, overview of APB protocol, APB bus architecture, APB signals, transfer phases, write transfer operation, read operation, APB timing and conventions, and error handlings, and some advanced features like APB4 and APB5. So both are same, but some extra signals will be added. That's it. And differences between APB, HB, and AXI, and real-time soft uses where we are using the APB in real-time socks. Okay. APB verification plan, UVM based perspective we are applying, and assertions and protocol checks, coverage strategies, and interview tips. Okay. What is AMBA? AMBA means Advanced Microcontroller Bus Architecture. That is the full form of AMBA. Okay, it is an open standard on-chip interconnect protocol. Okay, so everywhere everyone can use this protocol. Okay, it is an open standard on-chip interconnect specification developed by ARM. So that is the AMBA protocol. So it defines the family of buses. What type of buses you are using, that will defines a family of buses used for communication in between high performance processors, on chip memories, and peripheral in system on chip. Okay, so whatever the soft components are there, okay, in between the soft components we will communicate, and high performance processors also it is communicating, it is possible to establish the communication, and on chip memories are also we are using, it is also able to establish the communication. So that is the purpose of ARM. What is the main objective of ARM is provide standard interface for system components. Whatever the components we are using to communicate with our system, okay. So those components it establishes standardized interface. Okay, standardized communication is established in between the components and then systems, and enables high performance, low power designs. Most of the uh, our electronic devices need less power consumption. Okay, our mobiles are also designed in a such a way to consume less power. That is the main motto. And then speed should be improved. Okay, high speed operation is needed, less power is needed, and then latency is also reduced. Okay, so that is the main things we are working on these VLSI chip designs. See, supports scalable, reusable, and modular soft designs. Scalable means so we can identify how much complexity it is. Okay, and also reusable. We need to design the IPs with reusable because somewhat updations are needed in future. For that purpose, we use some reusable devices. And then key features are it is a open standard from ARM. Okay, everyone it is utilized, and then technology independent. Any technology we can implement, so that is independent of technology. High performance and efficiency is there. Okay, that is the main feature we are implementing the ARM processors. Flexibility in design and implementation. So if you have any complexity, it will be implementing. Okay, and supports wide range of soft designs, system on chip designs like CPUs, GPUs, and NICs. All these components, high performance devices. What are those? All devices it will be supports for communication and easy to learn and use. Okay, See, these are the AMBA protocol families: AXI, AHB, and APB. So still AXI light is there, APB light is there, APB4, APB5, and AHB or ASB. All these protocols are related to AMBA family. So full form of AXI means Advanced Extensible Interface. What is the type of the protocol is high performance memory interface, and then purpose is to communicate with high performance devices like CPU, GPU, and then memory interfaces. All these components, it establishes the communication. And AHB is the advanced high performance bus. So what is the type of bus is high performance bus. Okay, and the purpose of this protocol is used for high performance system components. So it is established the communication between the high performance system components like CPU, memory, DMA, all these communication. There is a bridges. Okay, for that purpose we are using AHB. APB is also most of the cases it's used like a bridge. APP to AHB bridge, AXI to APB bridge, and ASB to APB bridge. So why this bridge is needed means your right side having or left side having AXI related or AHB related. All these are high performance buses. Okay, high performance components, and the right side having APP. So these APP are low peripheral devices or low bandwidth devices. So how to communicate it? So I am delivering very fast and you are receiving slow means. So we need to synchronize with that. Okay. So I am delivering fast and you are not recognizing, and then waste of my time. So same way, we need to establish the communication between the low speed peripheral devices and high speed performance, high speed communication devices also. We need to establish the communication. So at that time these bridges are needed. APB or AHB bridges are needed. Okay. So APB is the advanced high peripheral bus. Here low power peripheral devices, it is a type of low power peripheral bus. Whatever the peripherals we are using, all these are communicating. UART, timer, GPIO, I2C, SPI, all these are low bandwidth and low peripheral devices. So this is the AMBA architecture. See, high performance bus on chip memories, and then AXI interface is there. So because we need to communicate in between these devices, we need AXI interface, and in between the low peripheral devices we need APB. So we need to connect with this APB to AHB bridge or AXI to APB bridge. So this bridge will communicate with the high speed devices and low peripheral devices. That is the AMBA architecture. So this is overview of your AMBA protocol. Okay. And then complete overview of APB protocol. What we are learning here. Architecture we will learn, and then key features, APB signals, and then write transfer timing signals, read transfer timing signals, key points of APB protocol, and then bus convention signals, and what about the APB protocol summary, how the phases will be happening, and then APB characteristics, where we are APB is typically used. Okay, all these topics we will discuss here. Okay, this is the AMBA architecture. I told you that. See, this is the high bandwidth external memory interface. Okay, so one device, this one high bandwidth external memory devices. What it is doing actually, high bandwidth memory interconnect, high bandwidth memory external interface is used to connect external memories, DRAM, and then SRAM, and then DDR, flash memories, NAND or NAR flash memories. All these external devices, external memories are there. For those, we need high bandwidth external memory interface, and high speed or handles high speed large data transfers. Why we need high bandwidth external memory interface means it establishes the communication between the external devices, external memory device, and also it handles large data. So for large data handles purpose also we use high bandwidth external memory interface. And wide range of data buses and burst transactions it will support. Okay, typically it connects through HB or ASB. Okay, high performance buses are connected through because HB is a interface. Okay, high performance interface bus. That means whatever the high speed peripherals are there, that will be communicated through HB or ASB. Okay, whatever the low speed peripherals are there, that will be communicated through APB. And then high performance ARM processors that execute all the instructions. See, processor is executing our instructions so in a high speed way. So instructions will be executing. Sometimes it will also do some read write transactions and it is initiate the read write transactions. Okay. See, initiate the read write transactions. Requires high speed access to memory and peripherals. So whatever the memory we are using and then peripherals are using, at that time we need high speed communication. So then only we are communicating each other. Otherwise not possible. And high bandwidth on chip RAM. And this is a internal memory. Okay, SRAM is a internal memory. So that is used for to store data and some other information. It's like it acts like a buffer. All these things we are using high bandwidth on chip RAM, and then it connects high speed buses also. So RAM will be communicating through high speed buses. So then only it will receive the data. This is the bridge. And DMA, direct memory access bus master. Direct memory bus access, what it is actually doing that performs data transfer without CPU intervention. That means without CPU connection, then DMA will transfer the data. And then move data between memory and peripherals. You are having some other peripherals and keeping some pen drives, and it will move the data and then improves the system efficiency. That is the purpose of DMA master bus we are using. Okay, so this is the bridge from AHB to APB. There is a bridge needed. So here APB protocols are UART, timer, keypad, PIO, parallel input output devices, keypads, and then so mouse and all these things are communicating through APB protocol. UART is a serialized communication protocol. Timers are how many events you have completed within the time. So that will count here timer. Okay. See all these protocols. See how it is doing. Brain of SOC. That is the ARM processor. Okay, it runs programs and issues read write requests. Okay, all are explained here. Same thing is also written here. And high bandwidth on chip memory is the fastest internal memory. Okay, SRAM. So fastest internal memory using to store the programs and then execute some other operations. Okay, and then temporary storage data, it will frequently access the data. Okay, whatever the high speed serial buses are there, it will frequently access the data. High bandwidth memory, external memory interfaces. What is the use of? It will communicate through DDRs and then some AHB interfaces or AXI interfaces. So it will communicate it and then connects that SOC to external memories. Whatever the SOC internal devices are there, so that will be communicating through external memories. That is the needed of external memory interface. And then AHB or ASB, so high speed, advanced high speed bus. Okay, and then so what it is doing here, high speed supports burst transferring, pipelined, and then multiple masters it will support. High bandwidth, it supports all components, it will communicate through CPU, DMA, and then RAM. So all these things are communicating through AHB. Okay. So DMA bus master, that means direct memory access. I told you, so direct memory without intervention of CPU, it will do the read-write operations in between the external memory devices and also transfer the data and then store the data. Bridge, it is a translator, converter. Okay, so it is a speed converter. high speed performance to low speed. So then it is converting the speed. See, high speed bus speaks with the complex or fast languages protocols, right? So always we are communicating with the complex and fast languages, so with the high speed bus. And also peripheral devices, that is a low speed, okay, slow clock, slow languages. So then there is a bridge is needed to convert to speak efficiently with the high speed devices to low speed devices. At that time we need a bridge. And APB protocol, advanced peripheral bus. It is a low power, non-pipelined, and then low bandwidth peripherals it is used to connect. And then it has phase transfers. Every transfer at least 2 clock cycles, and it has two phases, setup phase and access phase. All these things are supports here. See what are the peripherals here having connecting the APB protocol? UART, timer, keypad, PIOs, all these things. Okay. Understood what I am saying here up to this?
Yes, sir. Full brightness that only.
So these are the key features of APB protocol. What are the key features? APB is a simple peripheral bus of AMBA protocol family. So used to connect low bandwidth peripherals. That is the main feature of APB protocol. It is a low bandwidth peripheral device. Okay, and then APB is not pipeline. Then what is pipeline and what is non-pipeline? So non-pipeline means at one transfer is 1 clock cycle, it will do one transfer. So without completion of the first transfer, it will not enter into the second transfer. That is non-pipeline. In the pipeline means multiple transfers can overlap each other at a time. That means one transfer is not completed, the second transfer is initiated. The second transfer is not completed, third transfer is initiated. Okay, so that is the non-pipeline and pipeline difference. See, only one transfer at a time. See, one transfer at a time, that is the not pipeline. Next transfer starts after completion of the previous transfer. Okay, so that is the non-pipeline. Here what happens, multiple transfers can overlap and high performance will be happen. Okay, so that means the first transfer is not completed, some part of the second transfer is happened here. That means suppose in 1 clock cycle I am sending the address here. Okay, I am sending the address. In the next transfer, in the next clock cycle, I am sending the data. Okay, so here there is no overlap happen here. One transfer we are having address and data. So 1 clock cycle I am sending the address, and the next clock cycle I am sending the data. Then there is no overlap happen here. But pipeline here, one transfer I am sending the address one. In the next clock cycle, I am sending the data one along with the next transfer address. That means address 2 also I am transferring in the second cycle along with the data of first transfer. That is pipeline. Then the number of cycles are reduced in the pipeline operation. Non-pipeline operation, it will take somewhat little bit late compared to that pipeline. Okay, so APB is a not pipelined, is a low bandwidth peripheral, so that do not requires high speed performance like AXI protocols. So these are the signals. So signal transitions of the, see, every transition is happened at the rising edge of the clock. That means pause edge of the clock. We are having, this is the clock, this is the passage of the clock. This is the passage of the clock. Every transfer happens every passage of the clock. See, so this is the select signal should be 1. Here enable signal should be 1, and here the data is sampled, and here next transfer is happening. Valid data is maintained, and here some other data will be transferred. So this shaded region is ignored. Okay, there is no transition. That means there is no valid data in that byte. Okay, so that will be ignored. Clear? An easy transfer takes place. That means at least two cycles are needed. This is a two phase. One is setup phase and other one is access phase. And the default phase is idle. Okay, idle we cannot identify, so we cannot verify here. Okay, so we are not verifying the idle condition. That is default case. Idle is the default case. Okay, it will obviously verify it. So in setup phase, what it happened? We are selecting the signal. So through we are selecting particular slave through select signal. Select signal should be 1 means it is communicating with particular slave, and the next cycle, so enable signal should be 1. So both the enable select signal and enable signals are high means the access phase will be happen. So after completion of transfer, we are having any other data transfers pending, and it will again go to setup phase and select the particular slave and communicates with communication is happens here. Okay, so that is the APB key features. Same points here also there. Okay, where the APB is used non-pipeline and then simple protocol, register level access. All these signals, all these points are there here. APB is a AMBA protocol family, and it is not pipeline, low bandwidth peripheral device. Okay, at least two cycles are required. These are the differences between the APB and AHB. So high performance here, low performance. Pipeline operation, it is a latched control of bus transfer is there, simple interface is there. Multiple masters are there, simple suitable for many peripherals. There is no multiple masters here. Okay, so split transaction supports in AHB, APB is not there. Okay, so these are the key differences. See what are those. AHB is the advanced high performance bus, APB is the advanced peripheral bus. Both are AMBA family. Okay, here performance matters. Here high performance and then high speed and suitable for high performance systems. We are communicating through AHB, and APB low power, low bandwidth, and low peripheral devices. Okay, all are low power, low bandwidth, low peripheral devices. Okay, and then byte bus type. It is a pipelined bus. It is a non-pipeline, low speed, suitable for simple peripherals. UART timers, GPIOs, all these things. So we are communicating through it. Operation. It supports burst transfers. Okay, it is incrementing like increment by 4, 8, 16. So it will be possible. But here no burst transfers will be happen. Every transfer at least takes two cycles. One transfer, one clock cycle. Other transfer, another clock cycle. Okay. So that is the purpose we are using APB protocol and AHB protocol. So transfers here, single phase transfer here. Okay, here two phase transfer, setup phase and enable phase. In the setup phase we are selecting the slave, and enable phase we are accessing the data. And then clocking. So system clock, H clock is there. Here two clocks we will use. System clock. System clock is the P clock. So and then usually connecting with the other devices. Then other device clock also here it is utilized. Suppose it is connecting with AXI, A clock is used. Suppose it is connecting with AHB, H clock is used. Okay, H clock and P clock both are used. Okay, so because it is derived from the P clock is derived from the H clock, because APB clock is the slow clock compared to AHB and AXI, and it is faster compared to I2C. APB is the faster clock compared to I2C, and then it is slower compared to AXI and AHB. So that's why it is derived from the AHB clock. P clock is derived from the AHB clock. Okay, and these are the control signals. Like see here, H is common. Okay, H is the notation of each and every address signal is there, write signal is there, read signal is there, select signal, enable signal, ready signal, transfer, burst, and then protect signal. All these signals are common with in front of that every signal there is a letter H. Okay. Similarly, AXI also some other notations. I will explain while coming to AXI protocol. And then APB, here P is the notation. P select, P address, P enable, P ready, P data, so PRDATA, PWDATA, PSLVERR, all these things, P protect, and then P user, P wakeup. Okay, some different signals are there. So P is the common notation here. Okay. So large space is required here, limited space is accessed here. And it is typically 32, 64, 128 bits are accessing phase here. Here APB 32 bit. Address is also 32 bit, data is also 32 bit, read data is also 32 bit, write data is also 32 bit. All are 32 bits. And power consumption is high here low power consumption, and complexity is more and complexity is very less. And CPU, DMA and SRAM flash memories and high speed peripherals it is communicating here, and low speed peripheral like UART, GPIO, timer and all these things are communicating. So multiple slaves are selected by using select signal and select here single slave is selected using PSEL. Okay, in HP it can select multiple slaves. Here APB single slave is only selecting. Okay, and waiting period is there by using H ready signal, and P ready signal here also uses the waiting. And some slave errors like error, so OK response, error response, retry, split here slave error is there. Okay, so these are the differences. See, these are the signals APB, AHB and APB signals, and key summary. High speed pipeline burst transfers are support. APB low speed non-pipeline simple transfers are support here. Okay, and then so together APB and AHB is used for communication between the high performance and low peripheral devices. That is the purpose we are using AHB and APB. APP can compatible with backward like so it will also compatible with the high performance bus. Okay, so advanced high performance bus and a high performance light bus. Okay, and AXI light, all these are can interface with APP. And it is simple protocol. I told you low cost, low power, low complexity, low bandwidth. See, all are low, non-pipeline, simple protocol, ideal for peripherals. So these are the signals we are using. Okay, so APB AMBA signals P clock, P reset, and P address, P protect, P select, P enable, write data, strobe signal, ready signal, PRDATA, slave error. Clock signal is a bus clock system. Okay, it is a bus clock source. Every rising edge of the clock, it is changing the transactions. Okay, every rising edge of the clock, it will change the transfers. So it will do some read transfer, write transfer, or selecting the slave and then enabling the access. Okay, all these things are happened at every rising edge of the clock. Okay, if we have a clock here like this, okay, this is the clock. Okay, so every rise edge of the clock, we will do some transactions. And P reset time, it is an active low reset. Active low means if you are giving 0, okay, it is in reset condition. At that time, all the signals are 0. We are asserting the reset condition, that means all signals are initialized to 0. And if you are giving 1 here, then deassert your reset signal. Deassetting means we are giving manually values to each and every signal. Okay, that is the reset operation. And P address, that is 32-bit wide. Every transfer we will give up to 32-bit wide range of address signal. Okay, so that means up to 2 power 32 address ranges we are having. So that is huge address. And P protect signal, it will operates on different regions like secured, normal and privileged access, all these things. Normal means, so one master is communicating with the other slave. Okay, privileged access means suppose one master is communicating with one slave, so master 1 is communicating with the slave 1, and master 2 also try to communicating with slave 1 only. If it is master and slave having privileged access, then it will stop the master 1 communication and it is established the master 2 communication. Okay, so that is the privileged access. See, we are suppose one VIP came means, so all are entering into the main lane, but VIP is entering normally without entering into the queue, so he is having separate lane. So that is the privileged access here. Okay, secured access, so that means we have a secure transactions are also happening here. Okay, p select x, that is the select client for each slave device, which slave we want to communicate. Through select signal only we are communicating each other. And enable signal, it indicates that second and subsequent cycle of APB transfer. So one cycle we are selecting the slave and other cycle we are enabling that. Then the data transfer will be happened here. And PWRITE, so if it is high, okay, it is doing the write operation. It is low, it is doing the read operation. Okay, PRDATA, what it is doing, so we are doing the PWDATA means write data. That means master is putting the data into the slave, and then that is also 32-bit wide range of PWDATA. And then strobe signal defines that you are having some bytes of data, byte 0, byte 1, byte 2, byte 3. So number of bytes of data is there. In that, which byte of data is valid, okay, that tells about the strobe signal. And PREADY, so use it for extended transfers. Okay, so use it to extended transfer. That means, so ready signal we are doing some write operation and read operations. At that time we are doing some, we need to wait for that. Slave will send the ready signal. Okay, up to that we need to wait. Whenever the slave is ready, then only we will do the transfer here. Okay, we will do the transaction, so sending the information. Okay, so sampling the information will be happened here. Slave error means it is okay low means, okay, so okay low means there is an error indication. That means error is should be high. Okay, so when you are having the slave error high means you've done all the transactions, that is your last transfer. At that time you will put the slave error signal should be high. And then while reading also you get the slave error means you are receiving some corrected data, so corrected data you are receiving. And then while doing write operation you are getting some slave error means, so then that should be ignored. That means your p select signal should be 0, and then p enable signal should be 0, and p ready is also 0. At that time your slave error should be 1 means that should be ignored. Okay, so during read operation only all the operations are done. Okay, so then we will keep the slave error should be high. Otherwise, in between the slave error you came means there is a corrected data you are receiving. You need to check that. What is the address you are sending? One address you are sending and receiving from the other address. Then you will get garbage value. Okay. See, there is a mandatory and optional signals here. So control signals, select signal, enable signal, write signal, all these are control signals. If your write is high, okay, it is doing write operation. It is low, it is doing read operation. And then enable signal, select signal, both are high only, that data sampling will be happen. Otherwise, it is not happen. And then address and data signal, P address, PWDATA, PRDATA is the address and data signals. And then handshake signals, if ready is high only, handshake is happening and then data will be transferred. Error signal like slave error. Okay, clear? So these are the signals. And then bus notations. What are the bus notations we have? So bus notation means we have clock signal, and then high to low, low to high, some transition, okay, bus stable condition. Every signals, different signals you are seeing, right? Okay, so that notations we are explaining here. So this diagram explains the signal and bus timing convention used in your AMBA timing diagrams. Okay, shows how different signal states are interpreted related to clock. Okay, this is the clock signal. So every time clock is toggling, right? So clock is toggling every 5 nanoseconds or 10 nanoseconds, depends upon your time period. Okay, it will toggling the clock, high to low, low to high, high to low, low to high. In this way it is toggling. See, clock defines that sampling difference. Why we need clock means where you are sampling, at which time you are getting the signal and which time you are leaving the signal. Okay, so we need to mention, see, we are coming at 7:30 and then leaving at 9 o'clock, so 1.5 hours is effectively utilizing. So we have some start time and end time. So based on that, clock is measures that where you are started the transaction, where you are ending the transaction. That is the purpose we are using the clock. And then shaded or slanted regions means that is a transient undefined region. That is not a don't care about that. There is no matter in that. So we don't have any valid data in that slant region or shaded region. So that is invalid data. Simply ignore that value. We ignore that data. Okay. See, shaded or slanted region represents the transient or undefined value, meaning that exact signal level during these regions does not matter and must be not sampled. We don't have any valid data. We don't have to sample the data at that shaded region. Bus stable state. Stable state means it is a maintaining high values, both are high. So we need to maintain stable data during the transfer. Don't change the data during the transfer. Okay. Stable indicates that where the signal and bus holds valid and steady value. Okay. That is the stable indication that. Bus changing, that means you are changing one data to other data. So you are changing from here to here. Suppose here this is the stable bus. I want to change the data here. So then just give me the into mark here. This is data 1 and then your just give the into mark. This is data 2. Okay. So based on that we are changing the bus. High impedance to bus stable state and then bus to high impedance state. So this is high impedance. That means nothing it will be doing. It is not stayed on high. It is not stayed on low. In between that it is staying that. That is the high impedance state. High impedance to stable state we are moving. And then bus state. This is the stable state and stable state to high impedance state we are moving. Okay. So that is the high impedance, bus stable state, and stable state to high impedance state. Okay, so same signals here also represented here. Clock signal, each and every clock signal sampling will be happened here. See, every rise edge of the clock, your high maintained signal, and then low is maintained here. Low is changing here. In the next cycle, you want to change high also, it is possible. In the next cycle, you can change low is also possible. Okay, so high, low, low, high. So that is the falling edge, and that means high to low. That is the falling edge. So, but we are doing at every rising edge of the clock. And then transient, this shaded region, don't care about it. Okay, this shaded region we are not doing anything. So that is, there is no matter in that shaded region. We don't have to sample the data here. Okay. So